basically comes down to, if you say that the Earth is the center of the universe, or what I would, more precisely, I would say that the Earth is at rest in the universe. If you say that, then you have to explain what Newton's laws normally explain as due to the rotation of the objects in the solar system. So once you become a geocentrist, you also must become an etherist. You also must believe, in order to make logical sense of the laws of physics, you must use ether once you decide that the Earth is at rest.
All right, boys.
Sacred, you want to take this?
Yo, Pierre,
Shout out to the level heads.
Back to like Floyd Mayweather with this shit.
Always fucking Floyd Mayweather.
You tackle LeBron, that doesn't mean you beat him. Still crossed you up, he was still gonna dunk on you. You can't stop what's about that.
Okay, let's gather everything together. The alpha model, which means absolute lab frame, and fluid ether, is the model that I've adopted based on my own research and the research of Hildegard and of other people like the Russians. And here is my basic conclusions. The alpha model restores the biblical geostatism, that is, that the Earth is at rest, is confirmed by the alpha model, and heliocentrism is refuted. Modern physics has already refuted heliocentrism, so it makes no sense for people to argue that the sun is at the center of the universe, because no one believes that in mainstream. They all believe in acentrism, that there is no center to the universe, that any location is as good as any others. The absolute lab frame is used for dynamic predictions for both mechanics and electromagnetic theory. Remember that measurements apply to kinematics, predictions apply to dynamics. So whenever you apply the laws of physics, you must use the Earth frame. You must use the lab frame. The ether reference frame must be used for electromagnetic calculations. The alpha model promotes genesis and rejects Big Bang cosmology. No one has measured that. But we must know the speed of the ether in order to add the speed of light c, which is constant, in order to determine the speed of light. Represents about 3 decades of examination of science and looking at what's true and what isn't, using the criteria that I explained.
Yeah, you certainly put in the work, man, and it's great that you laid everything out. Your takes on it are super interesting, man, because we don't really get people to that come on and talk about this kind of stuff. So super fortunate to have you on.
Hey, Dr. Bennett, welcome to Flat Earth Fridays, brother. Good to see you.
Thank you, guys. It was a struggle to get here, but I finally got the voice connected.
We had faith in you.
Dude.
And you sound great, by the way.
And still.
Well, that's good, because I heard I've been breaking up on other conversations.
Yeah, your mic is perfect. Once you get used to navigating on Twitter Spaces, it'll become way easier. It's just like a learning curve. Oh no.
A learning parabola.
So I'd be a newbie.
You're a newbie today, Dr. Bennett. But it's great to have you. I appreciate you showing up last minute, especially on a Friday night, man. You really could be anywhere in the world, and you're here with us. I just want to say thank you again and again and again. It's just super appreciative. I know you put in a lot of work in your field of study. And it's just a privilege to hear you speak openly, because I know you said, some things that you really couldn't talk about while actually working, and now being retired, you are a little bit having more freedom to express your own ideas, and it's just super valuable to all of us. So I hope you can see that everybody in here have all been waiting for you, looking forward to hearing from you, and you really got a support system over here. So thank you very much for showing up, man. Thank you.
Well, you're welcome. Do you want me to address any particular topic, or I don't know?
How about a full-on presentation?
History of my background.
Yeah, you ready for that?
Yeah, how about we start with the history of your background, and then we get into the Newton's bucket.
Okay. Yeah, good idea. Well, I guess we could start with my first interest in science was in physics in high school, when it turned out that I could answer questions that other kids couldn't. And I was wondering why, because the answers seemed obvious to me. And then I had a decision to make to study languages in college or physics. And I said, with languages, I probably wouldn't make too much money. I'd be a UN interpreter or something. So I went for physics, and then after that, graduate school, and did a thesis on general relativity, which is ironic because what I did was support one of the predictions of Einstein's general relativity. And it turns out that after I graduated and I learned more about relativity, I actually opposed what I wrote in my own thesis, which was about the rotation of a satellite in a gravitational field. And that was tested once out in California. They sent up a satellite to detect whether the gravity field would cause it to rotate according to Einstein's relativity, and it did approximately, but it was a very, very sensitive experiment. So
Dr. Bennett, let me ask you about that really quick. So what happens? So because obviously when you get your PhD, you have to contribute something to science. But then if you find something later on in your studies that contradict that first position, well, how does that play out in the scientific community?
Well, what you usually do when you complete your PhD, you've written your thesis and you graduate, you usually go for a postdoc. You look to increase your research and contribute in some way, paying back to society what you've contributed, or what they've contributed to you in providing your education. Now, it's interesting. I got a 4-year scholarship to complete my PhD, and guess which government agency gave me the scholarship?
Uh-oh. Who wants to take the first guess?
Think moon. NASA. NASA gave me a scholarship to complete my PhD. And of course, I didn't get any offer from NASA when I graduated, and so I wasn't really interested in following NASA. So I got into teaching in a community college. Well, first at Manhattan College, and then at a local community college. After 15 years of teaching math and physics at a college level, I decided to quit, to retire, actually. Then I worked for a phone company, small phone company. I worked for Federal Electric, which is a government contractor. I worked for Bell Labs in Jersey. And then I worked in Chase Manhattan Bank, now JP Morgan Chase. And I was hired to help them connect with the internet, to start their business operations using the internet. And let's see, I worked there for about 10 years, and then I retired. And since then, I've been writing on the internet with monographs that support my view of what relativity should be, of what the distinction between kinematics and dynamics is, and various other topics like Newton's bucket, which is a key part of exploring what's wrong with mainstream physics. Excuse me. I think you could summarize what I've done since I graduated as being a dissident and exposing some of what I think are the fallacies and the misdirection and the misinformation that has been provided to the public through our public institutions, the colleges and universities, and government research, which supports what is mainly mainstream research. So I think that brings you up to date on where I am now, basically retired and able to do a lot of things that I couldn't do before, but not having as much intellectual what should I say, intellectual capability as I did when I was younger. So I'm looking for younger help, I guess, in exploring the ether and what it means to have a geocentric view of the world. So I think that should be enough. If there's any questions.
Well, I think you're in the right place for that purpose. And when you started to talk about how you were an intellectual dissident, all I could hear in the back of my mind was the military mantra, "There's no life like it." And I couldn't agree more.
Yeah. Yeah. Okay, you want to get into Newton's bucket then? Or?
Hold on 1 second, Dr. Bennett. Can you explain your position? I've heard you use geocentric and geocentrist and geostatist.
Right.
Can you explain to the audience the difference between the two and which one you appeal to, if not both or neither, or whatever the case is?
Sure. Geocentrism is the common term to mean that the Earth is the center of the universe. And when I'm asked, I usually say I'm a geocentrist, because to explain what I really believe in would probably be a distraction. Let me explain. Geocentrism, to be tested by the scientific method, would require that you know what the boundaries of the universe are. If you say the Earth is the center of the universe, that implies that you know what the boundaries of the universe are. And of course, we don't. The better telescopes we build, the deeper we can see into space. And so far, there hasn't been a limit where you get to a point where there's a sign saying, end of universe, go no further. So I guess you could say, another way of looking at it is the poles of the Earth could be extended. The North and South poles could be extended. I certainly agree that the Earth is on the axis of rotation. That is, we can obviously see everything around us in the cosmos is rotating, and it's rotating around not us specifically, but the polar axis of the Earth. Polaris, the North Star, for example, has a very small circle around the North Pole. It isn't exactly at the North Pole, but that doesn't circle the Earth. It circles the North Pole extended into space. So if someone could prove that the North Pole and the South Pole are of equal length as they extend into space, then that would be a way of saying, okay, the Earth is centered on the axis of rotation. And that would be one definition of it being central. But if you can't tell me what the boundary of the universe is, then you can't tell me that the Earth can be tested to see if it is at the center. Now, what I do believe is that the Earth is perfectly at rest. That I can prove using Newton's bucket and other tests. I can also appeal, and this may offend some people, I can also appeal to the Bible, which tells us in about 30 verses or more that either the earth is at rest, the earth is at rest, it cannot be moved, or it says the sun rises and the moon rises, implying that the sun and the moon move, but the earth doesn't. In no case in the Bible does it ever say that the earth moves, and it never says that the sun and the moon are stationary, except for that one case in Joshua's battle where the sun and the moon were told to stand still for a few hours so that Joshua could defeat the Philistines. So, what I'm saying is I'm a geostatist, which is the word you might use to indicate that the earth is at rest. But I'm not necessarily a geocentrist because I don't see how you could test that.
Now, that is a very honest answer, Dr. Bennett. Thank you for that. Now,
That is empirical purity.
exactly, right. And so what you're hearing, guys, is someone who has a wealth of knowledge in the science and physics and still says, hey, it is even hard for me to claim the center of all things because I would have to test the boundaries and I don't know the boundaries. So it wouldn't be honest for me to say that this is proof or there's evidence of it if I can't test it, because we all appeal to the scientific method, right? Trying to test causality and not just correlations. And you can have your own beliefs, but when we're talking about the actual sciences, there's strict parameters that we should stick to in order to make those positive claims. Now, we've got the definitions between geocentrists and geostatists. Thank you for that, Dr. Bennett. Now, when you hear the average person or mainstream science or the average globe earther claim heliocentrism, what are your thoughts on that? Because I've heard you use another term called acentrism. Can you break that down for the audience?
Yeah, heliocentrism means that the earth, that the sun is the center of the solar system, not necessarily the center of the universe, but then again, you have different branches of belief. And heliocentrism was introduced by, the famous event in history. Copernicus wrote a book, De Revolutionibus Orbum, concerning the revolution of the world. And that was supported by Galileo. And that, is a famous historical event. It overthrew the belief up to that time that the world was the way we see it. That is, as we look out into the sky, we see everything moving around us, which implies that we are at rest and the rest of the universe is rotating around us. But Galileo showed that there's a concept of relative motion, that if you were on one of those objects in the sky, say the moon, then the relative motion you would see would include the Earth. So the Earth would be in motion for someone on the moon because the person on the moon assumes that they are at rest. So this is what is called kinematics. That is proving something by measurement. And kinematics cannot prove whether an object is at rest or in motion. If you remember anything else from tonight, remember that, because a lot of scientists, including physicists, try to use kinematics to prove that the Earth is moving around the sun and the sun is at rest. That cannot be proven by kinematics. It can be proven by dynamics. And dynamics is a shorthand way of saying the laws of physics. Newton's laws are laws of dynamics. Maxwell's laws of electrodynamics, those are laws of motion, laws of physics. So the question was, just remind me what heliocentrism, right? That was the topic?
Yeah, heliocentrism versus acentrism. And then
Right.
I just want to delve into kinematics versus dynamics right after that. And then we'll go into your Newton's bucket for why it shows the Earth being at rest. I'm just trying to take the audience one step at a time because a lot of them may not know your history and why you appeal to the things that you appeal to. So I want to give them piece by piece before we get into the technicality. So you're doing a great job, Dr. Bennett. Thank you.
Thank you. Okay, acentrism means that there is no center. Instead of arguing, is the Earth at the center? Is the sun at the center? Is there some other object in the universe that's the center? Relativity says it doesn't matter. And that's the kinematic approach. It says, I can't tell by measurement whether I'm moving or not. And so we call that acentrism, which is the position of most mainstream physicists today. They believe that there is no place that you can say you're at rest or that you're at the center of the universe. And that's consistent with a kinematic view of relativity.
So let's just clarify that real quick, Dr. Bennett. So if you hear someone that says, hey, heliocentrism this, heliocentrism that, would you say that that's an outdated worldview?
Yeah, well, that's consistent with their education, because that's what all schools, public, parochial, private, almost all schools that I know of preach the mainstream concept of heliocentrism. To tell you the truth, the reason they do that, even though relativity says their doctrine is acentrism, is because it's anti-religious. It's anti-religious because the church originally insisted that Galileo declare that the Earth is geocentric, is at rest, because the Bible indicates that. And that position has been taken since the time of Galileo and Copernicus, and that continues to this day. Any indication that the world is not heliocentric is irrationally attacked, because mainstream claims relativity is correct, which means acentrism is their belief, and yet they promote heliocentrism because it attacks geocentrism, which is a biblical belief.
Wow, that is so. And guys, this is 106 episodes of Flat Earth Fridays. How many globe earthers, how many anti-flat earthers came through and have been preaching about heliocentrism week in, week out? And think about this, and I'm gonna let Dr. Bennett continue. Think about how many times you heard the guys, Whitsitt, for example, explain to these people who may not have a in-depth knowledge of the sciences or physics, like, hey, when you're learning grade school educational physics, that's not really applicable to current mainstream science. You're learning Newton when that has been like completely debunked or superseded or whatever you want to call it. How many times have you heard Whitsitt say that? And how many times have you heard them try to gaslight Whitsitt and say, hey, what are you talking about? You have no idea. And now you hear Dr. Bennett saying, some of the things that they're still teaching you in school today in 2024 is completely like just wrong. It's not what they appeal. I won't say wrong, but it's not what they appeal to. That's not their worldview in the highest level of the sciences. So just digest what Dr. Bennett is telling you guys and think about all the interactions we done had over here in Flat Earth Fridays on Twitter, week in and week out. I mean, it's really astonishing that it's going to take someone else, even though we've been saying it for this long, to say the exact same thing that we've been saying. It's crazy. Go ahead, Dr. Bennett, continue.
Yeah, if you believe in Einstein, okay, which almost every mainstream physicist will say, then you must believe in acentrism, because you can't claim that there's a center. And as I just said, those who insist on heliocentrism are, number one, conflicting with Einstein and all the relativists. And the reason they're doing it in most cases is because it's opposed to the historical opposition to the church when it declared that the earth is the center of the universe. All right, so it's sort of a mixture of religion and science that leads us to the way we are today, with such a confusing opinions about a simple question: is the earth the center of the universe? Is the sun? Or is neither? You can get different answers from different people for those questions.
Doesn't sound like the science is settled to me at all, Dr. Bennett. What you think?
No, it's not. But the trouble is, I think it hasn't even come close to being settled in the right direction, which is geocentrism. Most people believe in heliocentrism if they don't have any knowledge of Einstein's theory, and those that do have knowledge, well, they either will say acentrism, which is correct based on their belief, or heliocentrism if it's a religious objection. Shall we go to Newton, or Newton's bucket?
Oh yeah, well, one more thing before we get to Newton's bucket, right? Would you say then, Dr. Bennett, that mainstream science has somewhat of a biased agenda, which is the antithesis of how science is supposed to operate?
Yeah, I think there are certain elites, the ones who write the textbooks, the ones that teach in the universities, even the ones now that put out the science videos, because they have a big audience. They have the ability to affect the thinking of many people. And they've all been educated in the mainstream beliefs. And so a lot of people accept the authority of the scientists, even though the scientists themselves say that everyone can do science and objectively find the truth for themselves. That is, they can do the experiments and test the theories themselves. But realistically, most people, of course, are only interested in passing a course in school. And even those who are interested in science will accept the view of the authorities because they have the experience. They also have the ability to affect their grades and their future employment to a certain extent. So that all of this affects the acceptance of what I call mainstream theories. And I think it's indoctrination without people being aware of it, that they can do science for themselves. Well, of course, you can't do experiments in space like NASA can, because no one has the budget or the equipment, or in many cases the intellectual ability to build a spacecraft and do the testing in space. So there's obviously, and the other would be the particle physics. In order to test the theories of the smallest particles in nature, you have to build these enormous laboratories costing, they're approaching $1 billion now. And every time they find a particle, or even if they don't find a particle, they say, if we only had enough energy, we would be able to find the energies. So they promote their ideas to the government in order to get funding for exploration, which in most cases is not justified. If there isn't a real indication that they're going to find something new, then it's questionable whether they should get the money for these huge particle accelerators. I think
that's a great point that you made, Dr. Bennett. That's a great point. And, you know, I don't know how long you've been engaged in like this type of conversation when we talk about, you know, polarizing ideas when it comes to like flat Earth and, you know, globe Earth, the shape of the world. Obviously, you probably maybe met some contention with some of your views with, you know, being geostatist and with the ether. But we talk about this all the time about indoctrination and a select group of people that control all the information that we as a community or as a society digest. And we get ridiculed all the time by being honest, because you know we had to come to our own conclusions. We had to make a personal choice. What do we believe in, or what do we subscribe to? What can we test and verify, and what are they telling us is fact that we can't test and verify? And we had to come to our own conclusion. So when we say, hey, some of the things that you may be learning is indoctrination, or there may be a select group of people that are controlling the information and guiding how you think, we get met with so much pushback and ridicule, like we're the crazy ones. And it's just so interesting in hearing someone at the highest level of science acknowledge it. I mean, it's just mind blowing to me. I'm getting chills just listening to you, bro. That's all I wanted to say. I do want to kind of get into the Newton's bucket. Now, you kind of mentioned kinematics versus dynamics. To my understanding, just like how you were saying, they seem to be building our worldview off of kinematics, right? The measurement or relationship between objects in motion relative to each other, but not having the mechanics or the dynamics behind that motion. And I guess we could kind of move into the Newton's bucket. I don't know if too many people are familiar with that. If you want to go ahead and start breaking that down, feel free.
Sure. First, the distinction between kinematics and dynamics is very important. And one of the reasons we have such confusion in mainstream today is because that distinction is blurred or ignored. Let me just give you a brief definition so that we don't start off confused. Kinematics means measurement. So what you need to perform kinematics, it's very simply a ruler, a clock, okay, and observers, that is someone to interpret the readings. That's all you need. Physics, of course, is the study of motion. So by measuring distance and time, you can calculate speed, distance over time. And by calculating the rate of change of velocity over time, you can calculate acceleration, and so on. So that's the basic starting point of physics is measuring something to find out what it is, to quantify it. Now, there's another branch of physics. Oh, the first physics, the branch of physics that deals with kinematics is called experimental physics. One of the first things you do when you get your PhD is decide, am I going to go into experimental physics or am I going into theoretical physics? Okay. Kinematics belongs to experimental physics. Dynamics belongs to theoretical physics. And what is theoretical physics or dynamics? Dynamics is using laws of motion, like Newton's laws, to predict the future. So before you do an experiment, before you take your ruler and your clock and measure how something is moving, before you do that, you apply some law of motion, like Newton's laws, and try and predict what your measurement will be. So the key words for kinematic is measurement. The key word for dynamics is prediction. Okay, if you remember those words, you won't confuse whether you're doing a measurement or whether you're making a prediction.
Levelheads, write that down. Kinematics, measurements, dynamics, prediction. Keep that in mind. Continue, Dr. Bennett. Thank you.
Yeah, that is the key. And like I said, even at the highest level in physics, they'll confuse those two. They'll talk about something in a document as though it was predicted, and it wasn't. It was just measured. All right. So you always must look when you join a conversation, a discussion about science. Are they talking kinematics? Are they talking dynamics, predictions? Okay, if we have that definition, if we have that established.
Oh, yeah, and just real quick, guys, if you have any questions as you're hearing Dr. Bennett break some of these concepts down, feel free to tweet at me in the purple pill. We'll try to get to some questions afterwards. And some of the lads up here on the mic, feel free if you hear anything that's relevant to the conversation that Dr. Bennett is sharing, add it to the purple pill or share it up top so that way the listeners can follow along. We do have Shane and Alan live on YouTube right now. So for those who want to follow along that way, you could as well. But we'll be sharing some posts here and there throughout the evening as well. Just to give you guys a few different ways to get the information. Go ahead, Dr. Bennett.
Yeah, you can jump in whenever you want. This is a free form discussion. Okay, Newton's bucket. In 1687, Newton published the Principia, and it contained the laws of motion. It was an outstanding work of theoretical physics because from the experiments that he did, he derived three laws. The first law of motion, called the law of inertia, is that a body in motion tends to stay in motion unless some force acts on it. The second law says that the force that is exerted on an object, or excuse me, on a mass, produces an acceleration according to F equals ma. So, the third law is action-reaction, which says that when one force acts on another object, the other object produces the same force in the opposite direction. So there is a coupling of forces. Those are three laws of motion which form the basis of almost all of the physics that was produced after that by future physicists. All right, so we have these three laws of motion, and the question is, where do they apply?
Hey, real
Newton
quick, sorry
tested
to
them.
sorry to interrupt. As
Yeah.
Bennett's going through this, I got if you check the purple pill and you want to see graphics of what he's talking about with the equations and the bucket as he's walking through it all, you can just follow along because he's about to go through what he's about to go through is like the very fundamental and important. So anyway, please continue.
Okay, Newton's bucket. Well, first of all, the question is, where do the laws apply? Newton did the experiment in a laboratory. So he did this in what we call the lab frame or the earth frame at rest. NASA calls it the ECEF, Earth-Centered, Earth-Fixed Frame. Okay, so that's, if you're sitting at your desk right now, sitting, watching the screen, then you're in the earth frame because you're at rest with respect to the earth's surface. And that's what the lab frame means. So he knew that his laws were obeyed in the lab frame because he did all the experiments in the lab frame. But then he did an experiment.
In this, Dr. Bennett, Newton assumed that all space was fixed. That's why he was using this frame of reference as the value. Am I getting that right?
All space is fixed? Oh,
Yeah.
you mean, no, yeah, you're right, but the way you should phrase it is all reference frames are equivalent. All right?
Thank you. Yep.
That's the way to state it. In other words, no matter where you are in the universe, if you applied Newton's laws, the three laws that I just described, that they would be valid. So he assumed that there was a universal application of his laws. So in the lab, he took a bucket of water, suspended it from a rope, twisted it so that when he released it, it would spin. When you first release the bucket, the water is at rest because there has to be friction or viscosity between the wood of the bucket and the water. So when you release the bucket will spin, but the water will lag behind. But eventually it catches up because with the friction, the water will eventually rotate and it will form a vortex, a depression in the surface of the water. You can all do this, and I'm sure you can all do it in your imagination. You can imagine if you spin even a cup of water, you can see that a whirlpool will form, and the center of the water will be at a lower level than the edges. And the reason for that is centrifugal force. Part of Newton's law predicts the F equals ma part, predicts that the water will be subjected to a rotation, and that rotation will produce a force that depends on the mass of the water, the distance to the center squared, which is the radius, and the angular frequency, which is basically it's the RPM, the frequency of rotation. So the faster you rotate it, the bigger the radius and the bigger the mass, the more force there will be trying to fling the water away from the center. That's what a centrifugal force is. And so he observed this in the lab and he said, well, it's working. I applied the centrifugal force law to the water in the bucket, and it's doing what I predict from the law. He then said, suppose I were on the bucket and observed the same experiment. So here's where you have to do a thought experiment. Suppose Newton is watching a bucket spinning clockwise in the laboratory. Well, if you were on the bucket firmly attached to the side, you could call that the position of a bucketeer, someone on the bucket. That person would be fixed, and he would see Newton rotating counterclockwise. In fact, he would see the whole lab rotating clockwise, because he can't tell on the bucket whether he's rotating or the lab is rotating. But as far as he's concerned, the bucket is at rest, and it's Newton that is rotating counterclockwise. It's important that
did you guys catch that? So what he's saying is, like, when you're away from the bucket, you can see the bucket spin, but when you're attached, quote unquote, to the bucket, it's hard to differentiate what's actually in motion, because when you're attached to the bucket, it doesn't seem like the bucket is spinning. You just see everything, your environment spinning. Go ahead, Doctor.
In fact, relativity says that you can't tell which one is rotating by measurement. You can't tell by measuring how fast Newton is spinning, as seen from the bucket, or how fast the bucket is rotating compared to Newton. In fact, they're equal and opposite. So measurement, that is kinematics, will not tell you which one is at rest. But we're using dynamics now. We're using the laws of physics, F equals ma, and the centrifugal force law, to try and see if the laws of physics do also are also valid on the bucket. So we had the water rotating at the same speed as the bucket. So relative to the bucket, the water is at rest. In other words, if you were on the bucket, the water would not be rotating. You would see Newton rotating. You'd see the whole world around you rotating, but the water wouldn't be rotating because that's part of the bucket. So if you apply Newton's law to the stationary water, the calm water in the bucket, as seen by the person on the bucket, you would predict that there's no centrifugal force. Why? Because one of the things that is required is that there be a velocity to the water. Remember, the centrifugal force law requires the multiplication of the mass times the radius squared times the frequency of rotation. There is no frequency of rotation on the bucket because the water is stationary with respect to the bucket. So the bucketeer predicts that there is no centrifugal force. But when we do the measurement, we see that there is a vortex. There is a parabola, actually, formed on the surface of the water. And that's contrary to what Newton's law predicts if you're on the bucket. So Newton was puzzled by this, and so was someone named Ernst Mach. If you've ever heard of Mach speed, when applied to the speed of sound, Mach 1 means the speed of sound, and Mach 2 is twice the speed of sound, and so on. Well, the name MACH comes from Ernst Mach, who is the one who tried to explain the Newton's bucket experiment by saying it's the Earth and the distant stars that are affecting the water by exerting a force of inertia on it. And this is what is called Mach's principle. And there are physicists today who believe this, even though it is so vague and untestable that it shouldn't even be considered. In fact, even Wikipedia, if you look up Mach's principle, says that it's too vague and uncertain to be defined. Like I said, though, there are many people who claim that this is explained by Mach's principle. In other words, in some way, the stars, by some force, which isn't gravity, but some force of inertia, is causing the laws of physics on the rotating bucket to be invalid. So we have a problem for Newton and for all the physicists who followed. How do I explain why the rotating bucket does not obey the laws of physics? Newton said that the reason is there's a mathematical space called absolute space where everything is at rest. Well, no, excuse me. There is a frame in which everything is at rest that obeys the laws of physics. But if you are in motion with respect to that absolute space, then the laws of physics will not be valid. The problem with that is he never said where that absolute space is. It's a mathematical concept, which means it doesn't exist in the real world. And if you ask, where should I put my instruments in order to measure the absolute space, he couldn't tell you. So it was a way of explaining it using mathematics, but having no way of verifying it using the scientific method. So that has been a puzzle actually for how long? 3.5 centuries. And there has been no real answer to why do the laws of physics only be obeyed when you're on the Earth. But if you're moving with respect to the Earth, like the rotating bucket, or even if you're orbiting, if you do experiments on the moon or on the International Space Station, you'll find that the laws of physics are not valid. You'll be like the bucketeer. You'll find that the laws are not obeyed. So my solution to this is to say that the Earth is a fixed absolute frame of reference. It's the only frame in which the laws of physics are obeyed. This is contrary to all of relativity, which says that any reference frame is valid, even though we've known for 3.5 centuries, based on the Newton's bucket experiment, that this is not true, that the laws of physics are not valid on a rotating or moving frame, any reference frame that's moving with respect to the Earth. Now, physicists hate this interpretation that the Earth has a primary position in the universe. You could go back to Carl Sagan, who was a famous scientist and was very popular about 50 or maybe 40 years ago. He's on Johnny Carson. He wrote many books. And of course, he had what is called the cosmological principle, which says that the Earth is nothing special. It's just a little tiny speck in a vast, infinite universe. And that's called the cosmological principle, which says that there is no preferred location in the universe. Even though the Newton's bucket experiment shows that the laws of physics are only valid when you're on Earth, when you're stationary on Earth. Even if you were moving in a car or a plane or riding a bike, and you took measurements in those moving frames, you would find that the laws of physics are worthless. They're not valid. Despite the overwhelming evidence, there's an overwhelming number of mainstream physicists who deny that the Earth has this privileged position in the universe. And of course, this position has religious overtones because the Bible says that the earth is the center of creation. Okay, why is it the center of creation? Because that's where God's children are. That's basically the reason. But that is in opposition to what is presumed to be a science which is free of religious thought. So there is definitely a thought process in the modern world which says that anything religious is not scientific. And yet we see that if we use religious principles like the Bible agrees with Newton's law, with the result, I should say, of the Newton's bucket experiment. Now, this is a terrific break with what is belief today. I've known this for about 20 years, and yet I still can't get a group that understands the significance of this observation. And
well, you mean a group within the scientific community, right? Because you got like 200 people in here that completely understand where you're coming from, Dr. Bennett. I promise you that.
Yeah, well, I meant in the scientific community, because to tell you the truth, a typical cross of America would not be interested in this at all, right? They wouldn't be interested in hearing about Newton's bucket. So you have to have at least some scientific interest in order to accept and to understand what this concept is.
That's interesting that you say that, Dr. Bennett, because we've had other PhDs that came to Flat Earth Fridays. We articulated our position, and it's true what you say. If they don't have an interest, even if the information is valid, it won't be acknowledged. That's just my experience, as a few other people's experience, in the space every single week. And it's just interesting, that you highlight that. The other interesting thing that you said, and I want to make sure that I slow that down for the audience, is, all of, physics is done from Earth, yet they say that it applies to all the universe, right? But then it doesn't.
Yep.
So I don't know if you could just expand on that just a little bit more, because I really want that to sink in with people, because that's what a lot of I'm just going to say the scientific community, just for general terms. They rely on physics this, physics that, measurement this, measurement that. But then when it breaks down, they incorporate these abstract concepts, or they divert to different forms or different fundamentals of physics. When, to my estimation, me being not part of the scientific community, I don't have a credential, I would think that the scientific community should be working towards physics that is applied to all scales, no matter where you are. What do you say about that?
Yeah, the attitude of mainstream is to go along and get along. All right, that is, if you worked if you were a teacher, let's say, in a university, and you accepted the ideas that I just presented, that the Earth is a privileged reference frame, and the only frame in which you can actually apply the laws of physics. And by the way, it applies to Maxwell's laws too, the laws of electrodynamics. In fact, any law that's generated by what is called the Lagrangian, but that's going deeper into physics. Why they resist, I don't know. You could look at politics, right? Why don't more people get involved in politics? Because it's the government that decides, how you're going to live your life. And why aren't people more interested in science? Because it's the technology that comes from the science that determines a lot of the things that change our lives. Just look at what we're talking over now. We're talking over the internet, which didn't even exist 30 years ago. And we're walking around with phones that have more computing power than the huge IBM 360 that I used when I first started on programming. So I guess you get into human nature to try and explain that, and that's above my pay grade. I try to stick to physics, and I have enough opposition from mainstream to try and deal with that.
Yeah, I bet you're probably like their worst nightmare. Me and Proud, my co-host, we talk about this all the time. Like, if we had credentials, we'd probably be terrorizing the scientific community with all, the physics, the science, the papers or whatever they appeal to whenever we're trying to have just like a cordial discussion, in these spaces. They always are appealing to like academia, right? And it's just like, that's separate from science. I'm not going to say that there isn't a useful use case for, academia, but to me, those are separate things. But yeah, you probably are met with a lot of backlash or pushback because this isn't mainstream information. Like, this is something quote unquote fringe, and usually they'll categorize these type of ideas as quacks or something like that just so they could dismiss the information, and I think that's fallacious in itself.
Yeah, you know what a paradigm shift is? It's a change from one way of thinking to another. So we're talking about a paradigm shift here. Can we get people to understand that the Earth really is the only reference frame in which you can apply the laws, and in any other frame, the laws are invalid? Well, let's try to. I lost my train of thought now. I wanted to get some point across.
Oh, we were just talking about mainstream pushback.
Yeah, in your case, as in mine, you're trying to change the mind of a significant number of people, right? And there is a book written that explains what are the different steps in a paradigm shift. When you first go against the mainstream thinking, what you do is usually get ignored. Okay, so you, in your flat Earth point of view, and myself, in my uniqueness of the Earth frame point of view, are trying to change what the majority of the people think. And the typical reaction to that is to be ignored. Okay, just ignore them and they'll go away. Then the next step, I think, is that there is a violent reaction. When they see that you don't go away, there is a violent reaction to try and squelch the opposition. And I haven't had a violent reaction because my point of view is not that well known. But perhaps you can address that from your point of view.
Oh yeah, you should see my replies, Dr. Bennett. You haven't been active on Twitter like that, so thank goodness your replies, your mentions, your notifications are safe. But if you start talking about this type of thing in front of the masses, where people are heavily invested for some reason into a specific worldview that was given to them, oh my goodness, you are going to be met with backlash, insults, just derogatory remarks, and none of it will address any of the points with specificity when we're trying to have the conversation. So yeah, we're very familiar with that behavior from the other side, unfortunately.
Yeah, I'm only at the first stage. I'm at the stage where I'm being ignored. Okay, you're probably at the second stage where you're getting a counter reaction in trying to shut you up.
Oh, is that what
The
you
third
call a whole
stage
group
is
of
very
groupies?
interesting
Sorry.
because if you have the truth, it finally will be accepted when a whole generation dies out. In my example with science, all of the people who oppose me or oppose my idea, if I can promote it long enough to younger people, eventually the older generation of mainstream will die out. And the younger generation, which is more open to new ideas, will be more likely to accept it. And you know what happens then? What happens then is everyone accepts it as though it was always true. In other words, they totally forget that they once opposed it, and now they accept it. I mean, you could take something like they once believed the moon was made of what, blue cheese, and then just take that as an example. And then when they finally found out that the moon is made of the same basic material as the Earth, then that was accepted as though it had been always believed. So if you're successful with the flat Earth theory, eventually it maybe take a generation or two, but you may get a majority of the people to believe. Of course, there's plenty of examples where theories which are not true, of course, should not be successful. But it's interesting how people will change their attitude as time goes on if they are exposed to the truth. And eventually, I think truth will win out.
You'd hope so, right? If you put truth out there, people who are objective will find it, regardless of the people trying to obfuscate it. And when you say there's a direct reaction, would you say like a whole community of people who had sprung up to directly oppose everything we do, no matter where we do it? Would that be a direct reaction you'd be considering?
We still connected?
Oh, we can't hear me.
Oh, can you not hear Shane talking? That's just another bug of Elon's contraption that we're on right here. Don't know how to resolve that one. But Shane was asking you a question. I don't think I can compress it for you. Want to try again, Shane?
I would say Shane should drop down, and then maybe we'll try that.
Yeah, that's a deal. He's already gone. So when he comes back, he'll ask his question again, I guess.
Yeah, I think he was. I think he was asking about the reaction. When people dedicate, all of their time and energy into one thing.
How about now?
Maybe. Testing. Shane, can you hear?
I'm hearing him.
Can you hear me?
I can hear you.
Yeah, I do.
Okay, cool. Go ahead, Shane.
Perfect.
Did I not go up and come down?
No, you're good. No, we can hear you, Brody. Oh, he can't hear us now.
Bring your mic up about 15% and you're good.
It's the classic double reverse.
So sometimes, Dr. Bennett, we have connection issues. I know we're relying on Elon Musk for our servers. So sometimes certain people won't hear each other. So we're just going to drop them down and bring them back up if they have a question. But Shane wants to ask something. Did he drop back down again? Hold on. Let me try to bring him up one more time to see if he can ask that question. And then we'll get back to what you were saying. And then we'll get to some of the other hands because I think a few other people want to ask you some things as well. But I don't want you to lose your thought.
I threw one up to the post for you there, Sacred, for Barbara Dan.
Thank you. Appreciate that. Proud, try bringing Shane back up if you can. Shane, testing, testing.
I can't hear nothing when I come up to speak. So you can hear me. I can't hear anyone now. So just skip me.
Oh no.
Well, I can hear you. Can Robert hear him?
No, I did hear him for a brief moments.
All right, we'll try to get Shane situated. Maybe I could try to cycle him back up here. I don't know if you had like a thought that you wanted to finish on, Dr. Bennett. If not, there's a few questions for you.
Well, maybe you'd be interested in a letter that I sent out to Brian Keating. He is a promoter of mainstream science, PhD out at San Diego. And he promotes a lot of instructions to everyone to send in questions. He encourages, I should say, questions from those who are interested in science to send them into him for his responses. So I decided to send them basically what I described to you, the problem with Newton's law when applied to Newton's bucket. Because either he believes in absolute space like Newton, or he tries to make sense of Mach's principle, which nobody really has been successful in doing, or he has some other theory. But I can almost guarantee that he's opposed to saying that the Earth has a privileged position in the universe. That is, if it's the only frame in which the laws of physics are valid, then it certainly is favored over all the other places in the universe where the laws of physics are not valid. So I sent that to him. That was 2 days ago. I also sent it to 7 other physicists to see what their reaction would be. And again, it was just an outline of Newton's bucket, just like I gave right now. And it'll be interesting if anybody even answers the question, even though some of them promote themselves as great instructors and explainers of physics.
Dr. Bennett, so what happens with that? So when you send ideas, I'm guessing these are your colleagues. Are these people that you're cordial with, or are these people that you haven't talked to before? Like, how do you choose who to send what information to, and what do you expect to get back, if anything? Like, how does that work?
Well, some of them I'm familiar with, just from surfing the internet. Who, like, I'm sure you've heard of Neil in the Grass, my son, right? You've heard of him. and you and Brian Greene, maybe you've heard of him. Brian Cox. Yeah. So there's another. Well, what I actually did was I put a Google search for who are the top, physics. What was the word I used? Promoters, I guess, online. And then I got their emails, and I sent the letters. The answer to do I know any of them? No, I don't. Nothing personal. In fact, what happened since I left Stevens, which is where I got my PhD, I haven't had any contact with the instructors there. Most of them have died since I left. And once you no longer have a position in an institution, a teaching institution like Harvard or Yale or Princeton, you don't have the ability to post your ideas on archive. Do you know what archive is? ARXIV?
.org.
.org, right? Yes. It's the place where professional documents are published, or pre-published, I should say. They're tested, in other words, before they're put into books or used for research. So I can't even publish there because it requires that you have credentials from an institution that's approved. So they have a sort of censorship, scientific censorship.
You don't say. Wow.
Yeah, you don't say. Yeah, so even if you have a PhD, if you don't have someone who can vouch for you, you can't publish on this. And it's only preprints. In other words, they put it there to test to see if anybody finds anything wrong with it. It's sort of like a general peer review. And you can't even take advantage of that, like I said, unless you have, you're part of the club. You belong to the institutions, or you have some friend that will who's a professor at an institution who will give you the credentials.
So even with you, with all your tenure and your credential, it would be a struggle for you to even get access for those to publish something in that archive.
Right. I publish on a much more open platform, which is Vixra, which is archived backwards. So on vixra.org, they will accept anything. And so there's a lot of junk. There's a lot of, untested, wild theories. But it is like a public square, right? If you go to a public square, you can expect all kinds of opinions to be expressed. And that's basically what Vixra is. Archive is a filtered scientific platform for expressing your ideas.
See, I have a huge problem with that because, again, we've talked to other people with credentials. I mean, astrophysicists, particle physicists, nuclear physicists. They've all come to Flat Earth Fridays. Some don't stay too long, but some do come back. But we'll get gaslit, like, there's peer review, or why don't you go publish something, right? And then you'll have someone like Whitsitt or Alan or Toby, Shane, even my guy Indio from Discord. So they'll present these publications that are from these general, I guess you could call it, like how did you call it? Like a square, town square journal,
public square.
Yeah, public squares. Like anyone can publish, but then those same physicists who we want to look at the information will dismiss it based on where it was published. Say, oh, that journal or that publication is pay to play. Just like you said, it might be a little bit of junk here and there, but they'll just dismiss it all together. And it's like, well, hey, if they can't, get their information published in the right place due to this censorship, and they can only publish it over here, what other choice do they have? You're not leaving us any wiggle room to operate here if I can't publish it in a place where it's respected by you, Mr. Physicist, who's ignoring everything that we're saying. And if we publish it over here, where it might be alongside with other things that are maybe quote unquote junk or fringe ideas, then you won't respect it in that manner. So at what point can you get an idea across to the scientific community if you're not in that club?
Mm-hmm. Yeah. It's a small club and you're not in it. That's it.
My man, George
Poor
Carlin.
Carlin, I love it.
Yeah.
Yeah, it's super unfortunate. We're still here. We're still here. We're probably gonna get to some hands real quick, and then maybe we can expand in some of these other models and concepts and ideas that you have. I was super interested in hearing you talk about alpha. Maybe we can get into that in a little bit. But just to close it off, just for the listeners, Dr. Bennett, before we get to some of the questions, can you just highlight the issue with Newton's bucket in relation to how we view the Earth, like our worldview in current mainstream science? Like, can you just highlight the contradiction or the contention? Maybe that's a better word, just for the audience one more time, because this may be new concepts for them. And I just want them to really hone in on this, because this is the reason why you said that you took your position as, we're in a stationary frame. So if you could just give like a basic overview of just that whole thing, and then maybe we can take a few questions after that.
Okay. What I said about Carl Sagan is probably applicable to all of mainstream. They basically think that the Earth is nothing special, and again, that has religious overtones. It's a way of not accepting anything that they didn't think of. It's an elitist point of view, and it gives them control. I mean, all of this sounds like political rationale, but it also applies to science. They get a certain amount of respect if they all agree on a common body of knowledge, even if parts of that knowledge are false. Some of their beliefs can't be proven experimentally. Some of their interpretations are not logical. I gave a talk, I forget when it was, but it emphasized philosophy. The philosophy that underpins science is never stated officially. Scientists should believe that what is measured in the real world can be translated into a mental picture of the real world. In other words, that we can translate what we measure experimentally into what we believe as the laws that underpin the experiments, that predict the experiments. Okay, so a summary of the Newton's bucket is basically that there is a worldview that says that all points of view are valid for applying the laws of physics, that is, dynamics. Newton's bucket proves that that is a false belief. It shows that the Earth is fixed because only using the laws of physics in the Earth frame can you correctly predict the result of the experiment. In any other frame that's moving with respect to the Earth, you cannot apply the laws of physics. You must separate this from kinematics, which is the branch of physics that does measurement. If you measure the way the water moves, that's kinematics. If you predict the way the water will move, that's dynamics. So kinematics is fine. You can use any reference frame to do measurements. In dynamics, however, you must use the Earth frame. Now, my abbreviated summary of this is called alpha. Alpha means absolute lab frame, ALF. Okay? Absolute lab frame means that when you use dynamics, you must use the lab frame. The A part, or the FA part of alpha, means either fluid or flexible ether. If Newton's laws are not valid in a non-Earth frame, then how can you explain the motion of the cosmos, of all the objects in the universe, the planets, the moons, the stars? How can you explain them? Because Newton's law validly does that in the solar system. Newton's laws, in other words, are believable and workable in the solar system. But if you take the Earth as the center instead of the sun, then you must have some way of explaining how do all of these objects move without the laws of physics to support them, which you would use if you're not in the Earth frame. And the answer is, you can use this concept of ether, which represents a universal substance, the basic primal substance that exists everywhere. There is nowhere where it is not. And from that ether, you can build up a model that explains how everything moves. You can also explain how particles are formed by spinning vortices. We know that all particles at the elementary level are observed to have spin. So they're all spinning like little tops. We can explain that by the circulation of ether, called an ether vortex, that sustains it. We can also explain how they continue to spin without any extra influence from other objects around them by saying that there is an ether wind that is being supplied from outside the universe, which is part of what I call the Hildegard model, which I am presenting to the ether cosmology group, and we'll finish up on Monday, I hope. So alpha represents an ether model and an absolute lab frame. And as far as I know, I'm going to add H for Hildegard, because the Hildegard model that I'm talking about is consistent with everything that I've learned and developed in my own theories. So it extends it even more. And that sort of gives you an outline for all of my research interests right now. I also intend to investigate the experimental results of a Russian named Atsutatsky, who wrote about 600 pages of experimental results, and they all concern measurements of the ether. And no one, to my knowledge, has looked at the English translation and converted it into a workable theory, a consistent theory that explains what Atsutatsky measured. I hope that answers the question of what my research is and what Newton's bucket.
Atsutatsky is dense as heck, though. I wish somebody else would get through that and give us the summary already, don't you?
All right, fine, I'll do it.
I don't know if Bennett can hear you, Shane. Bennett, can you hear Shane?
I'm thinking that's a no.
Oh, did we lose Bennett?
Actually, I think we did, and we lost him on the net in general. I had him up in the Discord server still, and he seems to have dropped from there too. So yeah, he's gonna have to restart his browser at the very least at this point. So give him about 90 seconds. I imagine he might be back.
Oh no! Let's see if we can get sound like it was a issue on his end. Let's see if we can rotate him back up because I did want to comment on something and we
We
can
got
say.
about 4 hands in the air there too.
Oh, so I only see 2. Oh no, I'm glitching.
I
All right.
see two as well.
Yeah, the 4 being Superfly, Jonathan, Orwellian, and Run Boston, our El Presidente.
Oh, you're glitching, bro. Orwellian and Ron Boston not even up here.
Thanks, Elon.
Space-time spaces. Okay, let's do. While we get Dr. Bennett back up here, let's slide over to Superfly real quick. And if it is a question for Dr. Bennett, we'll just have him repeat it once we get him back. Although I do want to say, and I'm probably going to repeat this when Bennett comes back, but notice, I'm sorry, y'all. Just notice that he's using the same words that Witsit uses, while everyone Gaslight was talking about is word salad. You heard centrifugal, centripetal. You heard the convergence. That you heard all these different things that Witsit be saying all the time, and here you are. You hear the PhD physicist using the same vocabulary. Okay,
Yeah,
I'm
but
just highlighting that.
Purdue's word salad though, so.
You know, it's crazy. We're talking about the dynamics and the fundamentals of, you know, the ether and in general his belief, and all the Globers, all they want to know is whether he thinks it's flat or round.
Every single one, guaranteed. That'll be the extent of their
all they
interaction
care about.
with this
That
whole
is
thing. Yep.
crazy. Just spy. I'm seeing it too. I just don't even want to get into it just yet. We'll probably end it there. But like, yeah, that's all they care about, because it's just an easy way to deflect away from the information that we're presenting. Being that the ether is a more viable option than your dark energy and dark matter, no matter how spherical you think your Earth is, my brothers. Sorry. Anyway,
they will go through a reference on motion that's for a geostatist to prove that it doesn't move, and they'll be like their conclusion, yeah, but he doesn't think it's flat, right? So you're a retard. Crazy.
I bet you they won't want to talk about motion. I bet you they don't want to talk about that. Anyway, Superfly, you there?
Yeah, I am. You know, Sacred, thank you for having this. And I know I bugged you this morning. I said, hey, are you going to do any Flat Earth Party? You know, but listen.
Every week, man, you know we pulling up.
I know, but it's me. I didn't see nothing, so I didn't see nothing coming, so it's my fault. Look, I didn't have a question for Dr. Bennett, but he opened my eyes. You know, when you do my job, the job I used to do before, I retired from 28 years of working as a corporate pilot. Okay, you know, I couldn't spit the stuff out. I lose my job. You know, so when I learned that, when I caught on to, and I got excited because I knew that I lived on a flat Earth. Now, I mean, I lived on an immovable Earth. Why? Because at one time I was a, you know, hellacious Christian, and you know, and I still believe in God, and God says that it's immovable. God says that we live, that we have a, you know, we live like in a tent. And now we got this Dr. Bennett telling us that, hey, listen, it's immovable. It doesn't move. That's good enough for me. Yeah, you want to put me on a globe Earth, but now if we don't move, that's great. Now we're just kicking the shit out of these freaking scientists and astrophysicists and all these people that say that we move at 1,000 miles an hour. Well, I wanted to tell Dr. Bennett, well, what do you think about Felix Baumberger that went up to 127,000 feet, 24 miles up, and then came down and landed only 25 miles away from his you know, where he took off from? Hello? Are we fucking spinning at 1,000 miles an hour? Hello?
More
I
so
don't think so. I'll land right there with that.
He landed 25 miles to the east of where he started from.
Exactly. That's that part. Anyways, I just want to say thank you to everybody for listening to my little rant. But Sacred, love you, brother, and everybody else here for at least we're a force to not be reckoned with. You know what I'm saying? We are a unique kind of people, and let me tell you, I wish I would have lost my job a long time ago if I would have said I'm a flat earther. Because that you just don't answer those questions. You look like a fucking fool, being a pilot and everything in uniform, and then you're a flat earther. You get the hell out of here. But now it's a little bit more common. There's a lot more pilots now that'll tell you, that work for the airlines. They'll say, yeah, I think it's flat. I shot a picture out to you there, Sacred, of one of the cockpits I was working under. Hey, listen, I'll talk to you guys later.
Yo, shout out to you, Superfly, man. It's always good to hear from you. I'm just getting so much chills just listening to this conversation this evening. I mean, only because I hear all the time, oh, it's only you flat earthers, that there's no such thing as a pilot or whatever the case is that's a flat earther. Then you have someone that literally worked with the DoD. It's like, come on, y'all. He's telling you what happens when you in it. You can't really talk. You heard Bennett say it. You can't. There's censorship within these fields of study, and they want to make it. They want to have you believe that it's just all open, it's all transparent. Anybody could just present anything, and no, bro, that is not how it works. And the fact that we keep hearing this in 2024 from the average anti-flat earther or just the layman who doesn't understand the highest level of physics or how academia works. It's just refreshing to hear this from people with credentials, and I really appreciate your honesty. It's just unfortunate that if you guys aren't in your profession, you can't talk about it while in your profession. That's the only thing, because that's always going to hold us back. If we can't have the best and brightest minds speak about what they really want to speak about, it's just not going to help us. It's going to keep on holding society back. Imagine where we could be if we could speak freely and be accepted with all the ideas are more accepted, right? They're taken more seriously than just dismissed. So I appreciate you sharing that, Fly.
It makes me wonder if some of the pushback we get from some of these PhDs, some of these credentialed people is because they know they can't talk about it. It is because they know they can't discuss it. And if, their job, if their credentials got wind of them talking about this type of thing, they could potentially lose that position in science. So it makes me wonder if there is a correlation between all the pushback and the hate that we get for a reason.
That is a real good point, Rob.
Welcome back, Cassandar.
I'm on a screen I don't recognize, but I hear the voice.
We hear you nonetheless. Looking good.
Nice. It somehow worked out.
Are you on desktop or mobile?
Desktop.
There should be a window. How does it look, Alan? Is it a little window on the right side?
Oh yeah. So there'll be a little window on the bottom right hand side, and it might be minimized, so it'll be like a little sub bar on the bottom right. And then if you click that, it'll pop up the big window so you can see everybody again.
Oh, yeah. Well,
it shows Sacred's name.
What I see now is the Atsutasuki reference.
Oh.
With Alan. Alan's.
Yeah, that's the very top of the Spaces pop-up.
Yeah. If you mouse wheel down, you'll see us. You should be able to see us. We're under that.
So what you're looking at?
Okay.
Yeah, what you're looking at, Dr. Bennett, is when we're in Spaces. One of the only greatest features that I guess we have in sharing content is it's called the Nest. Some people call it the Jumbotron. So what we do is you can tweet things out, and then we can share it to the top of the space. So that way people can get visuals of some of the things that are being discussed. And it'll be like a bunch of tweets that are being shared. And anyone that's on a mic, not listeners, but anyone that's on a mic can share content to the top of the space. So as you're talking, some of the guys are just sharing some of the information that you were speaking about, so that the listeners can have a visual with the words.
Mm-hmm.
So, and when you get more familiar with spaces, we could walk you through how to do that, because you'll probably want to share some of your own content if you start engaging in these spaces more often. So, and it's real simple, but that's what you were looking at. That's just the shared content up top.
Wow, a lot of people here.
Yeah, a lot of support, man. We've been waiting for you to show up, so it's really good that you're here, man. Appreciate you.
Wow.
And we're getting a lot of feedback, so we're gonna get to some of these questions. I'm looking at my notifications. There's a few comments. We have Jonathan with his hand up. Jonathan, you have something for Dr. Bennett?
Yeah, I had a question about the bucket experiment and reference frames.
Go for it.
So I was listening to you talk, Dr. Bennett, and thank you for coming on here, by the way, and sharing. So I was thinking about how it does not, how the laws of, I guess, Newton do not hold in a rotating reference frame, like you pointed out. So sitting on the edge of that bucket, you're not going to be able to rely on equations, even though you look around that bucket and it seems to be stationary with respect to you. So that's a very valid point. I follow that. So like then my question is this: when I'm on a train, let's say that's going on a straight track, maybe it's a maglev, really smooth, very fast train, and I'm standing there in the middle of the aisle and I'm juggling 3 tennis balls. Well, as soon as that maglev starts to make a turn, and let's say from that point on, it's taking a turn of a constant radius from that point on. Now it's going in circles. So now I'm going to feel that centrifugal force on me, and so now the algorithms in my brain that I've trained since childhood basically do all those Newtonian equations for me organically. They're being messed with now, and they're no longer able to predict as well. And now I'm losing my orientation and I'm dropping these tennis balls. So the point is, I do remember being taught that as long as you're in an inertial reference frame, I believe is what they call it. So you're going in a straight line at a constant velocity, or you're going zero with respect to some other frame. As long as it's that constant straight line type of frame, then you have that equivalency, and you can juggle no problem. You can do a little science experiment where you launch a ball and then predict its parabola and where it'll land, all that stuff, and that can work on that maglev train going in a straight line. Is that not a valid distinction?
Yeah, Jonathan, we have to distinguish between whether you're measuring what you should do or you're predicting what you should do as you juggle the balls, right?
I guess we're predicting, yeah.
Okay, if you're predicting, then you must use the Earth's frame to correctly predict what you're doing. Let's forget about the turn. Let's just take the train moving at constant speed, right? Which is, according to the special theory of relativity, that is an inertial frame. But it is not that's not an inertial frame according to the definition I presented, which is that you must be in the Earth's frame. In other words, you must be standing on the tracks or on a station platform, stationary, in order to predict what will happen to the ball that you're juggling. Okay? If you try and use the reference frame,
I'm listening.
Okay, the train in constant motion is an inertial frame according to relativity, but it is not according to the definition I gave. Why? Because the train is moving relative to the Earth. Okay, just like the bucket water is rotating relative to the Earth. So if you're going to predict what happens in the in the frame in which the train is moving at constant speed, you have to observe the laws of momentum. You have to apply that is, you think you're in a stationary frame. You have to apply the laws that apply for a moving frame as compared to someone who's seeing this in the earth frame on a train platform. So the difference is that there would be a difference in energy, basically, between what you see on the platform, which is the earth preferred frame, and what you would measure in the train frame, which would be zero energy. So if we measure the energy, we find out that it's the measurement on the earth frame that is valid, not on the earth, not in the train frame, because in the train frame, the ball is moving along with you. It has no energy. But from the train platform, it does have energy. So the difference between the two can be measured, and only the one on the station platform will correctly measure the energy. There's other ways of doing it, but then I have to describe the forces that are on the ball, ignoring air friction, and only taking into account gravity, basically. And if you include the turn that the train makes, well, then that's another force that has to be considered. But if you consider just from point of energy, which is a law of physics, by the way, conservation of energy, that's violated on the train, but not on the station platform.
I guess the conservation of energy would be like let's say you pick your frame as the Earth or the train. I guess as long as you stay consistent with that choice, then from that point on, you apply the law of conservation of energy, and you should get the right answer. That was my understanding of conservation of energy. It's kind of like when you're working a circuit on paper, you choose what's ground. In some cases, it's arbitrary, and then you go from there, and you have to maintain and stay consistent with your choice. And then if you stay consistent, you get the right answer, assuming you don't make a mistake elsewhere. So that's kind of, and you've gone way further into academia than I ever have. So I'm not trying to question that, but I'm presenting to you how I learned it and kind of how I understand it, and seeing if I understand you correctly when you speak of a contradiction. And so just to reiterate real quick, you were saying that if you're on one of these other reference frames that isn't the Earth, that the laws of Newton no longer give you the correct answer. Is that?
Yeah, that includes conservation of energy, angular momentum. Maybe, Jonathan, I could give you a simpler example. Suppose you're riding a bike, and the bike is you come to a down ramp, and the ramp is a height h above the lower level. So you have two levels: the bike on the higher level, the lower level, separated by a height h. Okay. If you have conservation of energy, then the potential energy is mgh. That's the weight times the height, plus 1/2 mv squared, right? Which is the speed of the bicycle. That's the total energy of the bicycle in the Earth frame, right? So you're looking at a bike that's about to go down a ramp. The energy is 1/2 mv squared plus mgh when it's at the higher level. The bike goes down the ramp, now it's at a lower level, h is 0, and the energy that we calculate, total energy, is just 1/2 mv prime squared, where v is the new speed of the bike on the lower level. If we compare the two, let's see, we have the mass of the bicycle canceling out. There's an m on both sides of the equation. And this is the Earth's point of view, because we're using an upper and a lower level. If we calculate the energy, the total energy before and after, we predict that there will be a greater speed at the bottom because we have the extra factor of mgh. Now, if you're on the bicycle, what you calculate is a difference in the mass of the Earth, which is moving beneath you. Remember, if you're on the bike, you consider that as a stationary frame. So if you're on the bike and using that as your reference frame, then the bike is at rest. You go down the incline, and in order to do that, the Earth has to move minus h, has to drop and lose potential energy. And when you calculate it, you get that the energy depends on the mass of the Earth, which is totally wrong, because the calculation, when we make it from the point of view of the Earth frame, correctly predicts what the speed of the bike will be when it's at the lower level, when it goes down the ramp.
Maybe I agree.
Yeah. And
so you're saying that if you attach the original reference frame at time 0 to the bicycle and the rider at the top of the hill,
right?
Now, to keep that one consistent, that reference frame is going down at v0, which whatever velocity he started with, and the frame itself continues down at that sloped angle in a straight line throughout time. And so he's speeding up, and he's essentially leaving his original reference frame as he speeds up.
No, the reference frame must always be 0, okay? You must always consider yourself at rest. So if you're on the bike, what you do, you see the Earth, the road, moving towards you, right?
Yeah, the bottom of the incline is moving towards you. The Earth is moving towards you.
Yeah, if you were driving in a car and you said, okay, the car is at rest, then that means that the road itself is moving towards you underneath the car, right?
Right.
Okay, so if we actually measured from the bike, what is the motion of the Earth, it would be equal to the speed of the bike, but in the opposite direction.
Right.
Okay, when you go down the ramp, the same thing. It's as though the Earth came up to meet you, but the bike stays stationary. Okay?
Yeah, and the Earth would be actually accelerating up towards you.
Exactly. And then when you reach the bottom level and continue in a horizontal, then again the Earth is moving underneath the bike. Okay?
Right.
You have the idea then. The correct interpretation is, if the bike is stationary, which is a frame different from the Earth frame, then what you predict depends on the mass of the Earth. Okay, the same equation holds, except the m in the equation is the mass of the Earth, not the mass of the bicycle. And if you use that, then you get a ridiculous result that says there's an enormous amount of energy available just when you go down the ramp, because you're moving the Earth by a distance of h. It all comes out in the math, but I'm trying to talk my way through the math.
Yeah, and I don't have a piece of paper in front of me, but I do follow it. It's a fairly rudimentary. It's like the first, one of the first examples they gave you in physics class. So, and it is fun to think of it in reverse like that. But back to the reference frame though. We disagreed on what the reference frame is if you're the bike, and if it's an inertial. I guess my point was, if we're thinking of inertial reference frames, then that reference frame can't accelerate, otherwise it ceases to be inertial, right?
Yes. The inertial frame is, the reference frame is whatever the observer state of motion is. All right? Whoever's doing the measurement is at rest by definition. Because think of the contradiction. If you said, okay, I'm moving at 20 meters per second, well, then the question is relative to what, right? Whatever you're moving at 20 meters per second to, it's your true reference frame. Right?
So do we agree that the bicyclist is not representing an inertial reference frame?
Not according to my definition. Anything in motion with respect to the Earth is not an inertial frame. In other words, the only inertial frame in the universe is the Earth.
Okay, that's interesting.
Yeah, I think maybe I could summarize it. At the top, at the upper level, the equation is 1/2 mv squared plus mgh. Okay, and at the lower level, there's no more h, it's just mv squared over 2, but the v is v prime because you have a new speed, right? You have a greater speed when you go down the ramp.
Right.
Now, in those equations, the m, when you use the Earth frame, the m stands for the mass of the bicycle, because that's what you're measuring. When you're in the bike frame, the Earth is the reference frame, so you use the mass of the Earth. And you get a ridiculous answer. You get, megajoules of energy, because the mass of the Earth is included.
I'll have to think on that. That's thank you for sharing that with me, and I'll be thinking about that. And if you're back next time, then I'll give you kind of a summary of what I think after I've hashed out all my thoughts. Because my thoughts are kind of swirling, and that's pretty cool. Thank you for sharing that.
Well, Jonathan, you can always get me at my email.
I would like that.
Okay, it's Robert.Bennett.
Well, don't share it here, but I will. Okay. I will follow you, and then I'll ask you in a DM.
All right. All right. Thanks for the question.
I appreciate it. Thank you.
Dope stuff, Jonathan. Appreciate that, Bennett. I thought there was somebody else that had a question. If not, there is a few.
I think in order for that communication to work, Doctor, is that you also have to follow Jonathan. So he's just down a bit on the list from you there. Check Jonathan Brown and hover over his icon. Pop-up will show up top right. Click the follow button just for him. And that'll open the communication conduit between you guys in the messages section in Twitter.
Wow. Thank you, Stone.
What is your screen name on here, Dr. Bennett?
That would be Cassandar, C-A-S-S.
Thank you.
A-N-D-A-R. Got an echo.
There is a couple questions from the audience. Hold on one second. Someone says, oh, this is RG. He says, would there need to be a new set of ether mathematics created for technology to improve?
End of the question, if we are to move forward, as in without mainstream education, incorrect education, you know what I mean? If we're going to move forward with new knowledge, is there going to be a new curriculum, I think is what he's driving at.
Well, he mentioned math. Will a new math be needed? No, I don't see any new math. We can talk about an ether wind, but that can be described with the normal means of measurement, distance and time, with rulers and clocks. Actually, what's needed for a new ether understanding is fluid mechanics or fluid dynamics. And instead of thinking of everything as particles, we can think of ether as either a fluid which flows or a vortex which has the property of particles. And that's the new way of thinking. And we still have the math to deal with that. I don't see any problem with describing ether using the math that we have today.
Regarding the vortex mechanics, I think my prediction would be we're going to see a revisitation of some of the work of Victor Schauberger in that context.
Not familiar with Victor.
He's all about implosion dynamics to do with vortices, and he did a lot of his work with water because it's out of his background in Europe, working with water flow for tree extraction, like creating artificial rivers and that kind of thing to begin with, and eventually even moved into aircraft form, repulsors, and you might look up his work. It's actually really neat. Victor, V-I-K-T-O-R, Schauberger. Yeah, very interesting guy.
Okay, writing it down.
I'll send you an email of a video breaking down his work. It's a really great summary with some experiments and stuff. I'll also put it in the jumbo for the boys.
Victor with a K.
Yep.
Yep, that's the guy. Just another guy who came out with some brilliant geometries who was viciously attacked by the mainstream.
Yeah, kind of characteristic. I'm going to talk about the rotation of ether in the Hildegard talk on Monday. It's going to be applied in a very strange situation. The rotation of the drive shaft of an automobile has to have its axis of rotation changed from the drive shaft to the propeller shaft and then to the rear axle. And that involves a change of direction of the rotation. And that can be modeled as circular vortex rotation. And it leads to some interesting consequences when we apply it to the solar system. Anyway, that's what's going through my mind when I think of applications of vortex motion to the real world.
Yeah, it sounds like you're learning or moving, rather leaning towards radial torque as the motive.
Yeah, the model of Hildegard was a series of vortex winds centered on the sun, the moon, and the earth. The one on the earth is the firmament, which rotates the stars. So how do you have these vortices interacting with each other. That's one of the problems that mathematics can address, and that's what I'm going to do on Monday, hopefully.
Cool.
Yeah, I caught the part of the part one, and unfortunately, the second part had to end a little bit. But I'm looking forward to that part too, Bennett. I'm not gonna lie.
I'm not really objective, but I think that's going to be the most interesting part, compared to what I presented on what was it, Thursday or Tuesday, whatever it was.
Well, I'm not really objective, but I'm sure it'll also be awesome.
Did Shane have some question?
But yeah, Shane, you dropped down earlier. I don't know if you wanted to revisit.
Can you hear me now? Are we audible?
I can hear you.
Yeah, you were going through the steps of like when you have like oppression or when you're successful in science, and I was like, oh, you mean when there's active resistance? And I was like, oh, you mean like when there's a whole group of people who make it their life's mission and work to get together and oppose us at every turn and every place wherever we go on the internet? You mean like that? Would that be a direct reaction? Would you think?
You mean you have organized opposition?
We have a fan club that went like super hard in one direction specifically, and now they're like what you'd call anti-groupies, where they hate us so much they have to follow us around all the time and tell us everywhere.
You know what they say, Shane? You know that you're over the target when you get hit with the most flack.
Interesting.
So that's actually a credit to you're hitting a sweet spot if you're getting a lot of opposition.
That's good to know. That's good to know.
What an excellent impromptu physics lesson for everyone on Twitter, huh? People like, this was excellent. It's like I couldn't have worked out any better, honestly. Good thing we didn't plan it at all. We just kind of winged it, huh, everyone?
Right. Hey, you should see some of the replies. I mean, the anti-flirts are kind of losing it. I'm trying to find some of the level heads questions. Maybe they're just buried underneath all the triggered like anti-flat earthers. But
I sent you some of the ones I found.
oh, thank you. Because I'm like trying to filter through to find like some, substantive value in some of the comments in it. I just see a bunch of triggered anti-flat earthers, and we're not even really talking about the shape of the earth right now, guys. So relax.
I was gonna say I haven't read any, but how many of them are just like, what shape does he think the earth is?
Bro, they're all saying, oh, they're gonna turn on Bennett. You just wait, they're gonna turn on. I'm like, bro, y'all know, like we've been rocking with Bennett for like probably over a year now. Like, y'all should do your homework. Y'all should, when we send you to the YouTube channels, when we send you to the Discord, you guys should actually go. Because if you were to go, you would see that we've been talking to Bennett for a long time. But the problem is every time we direct you to get some information, y'all never look at it. So y'all just be in my mentions saying things week after week, the same debunked, nonsensical like rhetoric that just don't apply to anything in reality. So I'm glad that Bennett took the step to come over here because y'all wasn't going to go over there. So y'all getting a firsthand experience of what it's like. Some of the information that they talk about on a literally almost a daily basis at this point. I mean, go over to Ether Cause. I mean, it's like Monday through Thursday, like every single day they're breaking something down. Let me see what Proud sent.
It is the metaphorical air we breathe over there.
They should just know by now. We've been doing this for so long. Like, the goal is to have the conversations, to talk to many of the minds, not just to solidify our position and what we believe. Like, we want to hear from globers, we want to hear from geocentrists, geostatists. We want the minds to merge so we can come together and find some type of answers. So just more straw mans of them trying to project onto us.
Yeah, that is the paradigm of the public square, is to include all of that dialogue. That's actually something I wanted to mention in passing here. I'm seeing a new issue in people trying to convince anybody of anything using a video on the net anywhere. And particularly in the flat earth community now, I'm seeing a lot of situations here. Jason Hubler is one of them. I saw, I think this morning in a video he released recently, saying at the end of the video, he addresses the audience directly and challenges them or confronts them, so to speak, and says, hey, if you're still an X, whatever, a generic thing that I don't align with, as in if you're a Globie in this particular case, after seeing the evidence I have just presented, then disconnect, unfriend, unsubscribe, get out of my net space. Do not be here. Do not listen to anything else I say. Do not comment on anything else I produce. Do not be involved. And I think that is counterproductive to progress. I think it is the antithesis of the public space. I think it is a little on the arrogant side. It is excommunicative, and it is far more detrimental than it is anything else. And I'd like to tune this crowd to begin with, and maybe you can help in your reactions and comments to people who say this kind of thing in future production, that we need to cut that right off. That's just creating echo chamber, and especially the Globies. That is something they notice. That is something they discriminate against and tend to treat it like it's something they're going to expose as a weakness of our platform. And we got to cut that out, guys. That's what I needed to say.
Yeah, that's really no different than when the Globers expect, you know, the whole entire heliocentric model to be explained by one little thing for flat Earth, and then them to understand it immediately. Like, they expect us to have one answer that summarizes everything they believe to be true. And if we can't do that or provide that, then our model just doesn't work automatically. It's end all be all. And like, yeah, that's a very negative way to look at it. It's a very negative way to approach it, because you didn't even learn the heliocentric model in one day. So yeah, everybody should stay open-minded and just understand, like, it takes time for this information to resonate with you. Sometimes it's only going to be one piece, it's going to be one part of it before it actually clicks.
Indeed, all of that inclusively. But the specific point I'm trying to address here is a mental vector that is turning off the dialogue, and that is systemically antithetical to where we want to go.
Guys, I'm going to have to bail out. It's past midnight here. So
glad you could make it.
I invite you all to Monday, 8 a.m. at the Discord location. I guess it's a roundtable ether cosmology.
Yep. We will definitely see you then. Thank you so much for showing up on time and giving us a wonderful show on cue, on Winging It, right? Cheers for winging it, everyone.
Nobody on stage has any questions, right? Any last minute comments or anything, since you have a mic?
I do. I was just about to holler at him. Mr. Bennett, you still here?
Yeah.
Really quick, before you go, I had just one question. So you kind of come from a biblical perspective in some aspect of your thinking, which I can appreciate, because I do believe there is truth in the Bible, even though I don't believe in it the same way as others do. So I wanted to ask you a question about which parts of the Bible do you get most of your influence from? Would it be the beginning, where it's basically the Torah, or would it be later, where we get into Jesus and his interpretation of things? Or is it both?
Well, I would say let me change it a little and say what my favorite parts are. That would be, awesome. Yeah, Genesis and all the epistles of St. Paul. Those,
awesome. Thank you so much.
I mean, that's where I draw most of my inspiration, is from those two areas. Revelation, if I could understand what Revelation was saying, I would probably include that. All right.
Thanks again.
You're welcome, guys.
Dr. Bennett, there's one more. I think there's one more question for you. If you have just a little bit more time, just a couple minutes.
Go ahead.
I think Rum Boston has something to ask.
Yeah. Hi, Dr. Bennett. JT here, Rum Boston Bear. I just wanted to pop up and thank you for the time you spent with us tonight, the energy you put into teaching. You have a very, very humble approach, and anyone that hears you speak and teach knows that whatever truth you find, you move towards it. And I really like to hear your faith. I like to hear your passion. And I just appreciate you. I just want to say thank you.
Well, thank you, JT.
Okay, see you on Monday.
Yeah, good. It's a deal. Bye now.
Later.
Thank you, Dr. Bennett. I appreciate you, man. You guys go follow Dr. Bennett. His at ROBERTITNOTF. In Ether Cosmology, we're doing a lot of discussions over there as well. And Dr. Bennett, if you ever want to come back, it's always open. You're more than welcome. As you see, there's a lot of people that appreciate you over here and probably other platforms that you're not aware of. And I'm just happy and thankful that we can bring everybody together and you can see the support that you have. And we appreciate everything that you've done thus far. It's been great. I know I've learned so much in such a small bit of time just by looking at some of your content with you working with Alan and Toby and Shane and Witsit, especially. I think those are the first. My first introduction was through Witsit's page, and ever since then, man, I never looked back. And I really appreciate your honesty. Again, it's a breath of fresh air. Thank you so much. You are setting a new standard in this conversation, with or without the credential. And I just want to thank you. And you are always welcome back to Flat Earth Fridays, my brother.